Okay, so in this class we'll do the last question, question 18, on page 233. So open your textbook, page 233. I'll read the question for us. Several electric bulbs designed to be used on a 220 volt supply line are rated 10 watt. So let's just write the information starting from now. Here V is equal to 220 volt is the voltage supply, right? Watt means power, so power is 10 watt is the power of each bulb. Okay, bulb or lamp, it's the same meaning. Then PV, resistance of this bulb, each bulb we don't know, so let's just first find out the one. So this is the R, signifies resistance of each bulb, or we can also say lamp, which means the same thing only. Now we know the four power equations here. P is equal to E by T or W by T, P equal to V into I, P is equal to I square R, and P is equal to V square by R. So in this three information, P, V, P, R, to find R, V, P, R, the last one is the appropriate one in this case. So let's just use that last one. Since power is equal to V square by R, we know this power equation because we are well acquainted with these four power equations even earlier, right? These are the main four power equations that we're going to use in this chapter electricity, right? So if we were to shift this R to the left side, it will go to numerator and multiply with P. So this will be V square. So we are trying to find R, so R is equal to V square by P. So V is 220 volt, so 2 times 220 volt, because this is V square by P here, as you can see, 10 watt. See here, 220 V. So V square 2 times we've written. So that will give you equal to, next step, 220 into 220 divided by 10, and since everything is in the SI unit, V, volt, watt, so SI unit on the left hand side, resistance is ohms. We can just write like that. These two cancel, then 220 multiplied to 22 will give you 484 and 10 here. So each bulb is having a power of a resistance of 4840 ohms. Let's keep this one as 1. So we found the resistance of one bulb, each bulb. So now the question is asking us something, so let us go and see how many lamps can be connected. So let n be the numbers of lamps connected in parallel. This is important. Parallel across 220 volt line. I'm writing in short, across, according to question, 220 volt line, and line, if the maximum line, question is saying if the maximum allowable current, okay, allowable current, maximum allowable current, let us say I is equal to 5 ampere. This much is given. So we know here I is there, V is already there, so you can use Ohm's law. So using Ohm's law equation, which is the famous equation we're well versed with, V is equal to I into R, right? Before that, before using the Ohm's law, we have to find the total resistance. So since the n number of bulbs, each having 4840 ohm power, is connected in parallel, we don't know how much is n, so let Rp be the total, okay, the total resistance of n numbers of bulbs or lamps. So since it's in parallel, clearly formula is reciprocal of total 1 by Rp equal to reciprocal of one resistance is here 1 by R. R is the value of each resistance multiplied to n, because there are n number of bulbs, means 1 by R plus 1 by R plus 1 by R n times. We don't know n, so we can multiply it to n, right? So just as 1 by x plus 1 by x plus 1 by x 3 times is 3 into 1 by x. So 1 by R plus 1 by R n times will be n into 1 by R, right? So with this we'll proceed. As we proceed here, that will give you 1 by Rp, we don't know, equal to n into 1 by R value. Here we have 4840 ohms, and we can write here, since using equation number 1. We can just bring it in the format of R. So Rp into n into 1 is here, Rp into n. Okay, so up and down multiply, then 4840. So we can just bring here this one into this, then this you shift here 1 into this is here 4840, right? So Rp into n, okay, 4840, this much ohms. So 1 divided by, sorry, this ohms should be in the denominator, because you see here clearly, here see the formula is R is in the denominator and R is 4840 ohms in the denominator, sorry. That way 1 into 4840 ohms will be ohms also here. So Rp you find out is equal to 4840 divided by here n will come down this much ohms. Let us just keep it like that. That's equation number 2. This one is equation number 2. Let us suppose. Then once you're through with that, you can write here. Now using Ohm's law. Ohm's law is the famous Ohm's law equation. We are well versed with this. V is equal to I into R. The total here is Rp. So just put Rp. Then let us change this into the format of R. Rp, then here V divided by I will come down. So this V is, we know, 220 volt as we written in the beginning. By current allowed is maximum 5 ampere. As you can see here, I equal to 5 ampere. Rp is here now 4840 divided by n this much ohms, and we can write here, since using equation number 1 and knowing that V is equal to 220 volt, comma, and one more, I maximum allowable current is 5 ampere. All this information we have. That's why we replace this V by this 220, I by 5 ampere, and Rp by this value here. Once we're through with that, then it's just a matter of calculating. Now we know volt by ampere SI unit, so that will change to ohms. 220 divided by 5 ohms is equal to 4840 divided by n ohms, as you can see here. So this ohm, if we shift, will go to the denominator and cancel this one, so we may as well cancel it from here itself, from this step. And here 5 4s are 20, 2 in hand, 5 4s are 20. So if you cross multiply n into 44 is 44n, 1 into 4840 is 4840. So how many bulbs or lamps they're asking? So we're going to write here, and the required number of bulbs is 4840 this 44 will come down. This many, no unit, right? So 11 4s are 44, 4s are 44, 4 and 4s are 44, 0. Then 4 1s are 4, 4 1s are 4, 1 0. So 110 numbers of lamps. 110 lamps should be involved. That's our answer. So that concludes the part for test 12J. Now you can go and give the test. I hope that's clear, right?